Okay, I will now explain my experiment, replication. First, we need to create the data. So, the random walk will start in state D. I represent as 2, and it will end in the terminal states for A and G, -1 or 5. And there's a 50-50% chance that it will go to the left or the right, okay? M is the parameter for how many sequences you want. There are going to be 10 in the experiment. And that will be for the amount of training sets we want. Okay, so now we need to look at this equation here for the delta update, because that will be implemented here. Okay, and we use this eligibility E value that is here for the summation, and that makes things much faster. And we see that if we know that t plus 1 is at 5 or -1, then we know the value. If not, then it's the weight. And PT will always be a weight, and that's because when we run it through this method, we will loop through the entire training set. But if it ever gets to 5 or -1, we don't accumulate anything for the delta. We simply reset the E value and continue. And as you can see, E is set to 0, delta is set to 0, and the W is 0.5, and there's only 5 of them. So this is using Python, and I'm using lots of NumPy arrays. So for the first experiment, we needed to converge to this as the epsilon value. And for the second and third one, we need to use this method. For some reason, I use this one for convenience sake. And since it does not converge, it will just break after it finishes the entire 10 sequences for the training set. Okay, so now, oh, here's the error function right here. You can see it's the values it should be, and the values, and then the mean squared, and then that's all square rooted. Okay, so create data. This will be the first experiment. I set lambda, or not lambda to those with lambdas, but I set the alpha to 0.005 because it eventually converges with the epsilon I had. Here is the second experiment. So here's the lambdas that were given in the paper as well. And as we can see, I printed some of the errors. And then the third experiment is right here. Very similar, except it's going to find the best error, or the lowest error. And graphs. Okay, that's about it. Okay, thank you.